It's on mute.
Okay,
So they
fine.
should be able to let me just see.
Okay.
Yeah, do you want to do share screen?
Presentation.
Okay, just wait
Yes.
for Bob. Bob will introduce you.
Okay, okay, sure.
Are you the one who asked for questions from Zoom?
No.
No? Oh, hi. sir.
You know, the export, you know, wow, I read the export. Oh, okay. They go. I'm not exactly defined here for one of the last. Yeah. With them prime here for that.
Hey,
How are you?
Late 20s, early 30s, you know, yeah.
thank you everyone for waiting. We have Suman here. We're going to talk about building a serverless pipeline. Thank you so much for attending and for your time.
Thank you so much. Yeah. Okay, is it the need? Do you find or else I can matter? So.
You know, the room has been pretty good for just talking.
Okay, perfect. All right, so let's get started. So, hello everyone. Thanks so much for your time. After lunch, and as you can see, I'm running slides, but we just talk at slide number 3. Okay, and we will get some handful of more on that side. All right, so what we're going to do is we are going to let me put so what we're going to do is we are going to build a data pipeline, a very simple data pipeline in 30 minutes or so. The idea is how you can make use of serverless in your data processing pipeline. We will take one small data set, a very broad data set, just to give you a motion of how things work. But we can always replace that data set with production to data. That's not important. What is important is to understand how you can leverage serverless to build a data pipeline. So there are a lot of AWS services which I'm going to use, but how many of you are aware of AWS services like S3? Oh, quite a few. Oh, that's good. I know. Okay, so we will try to learn these services as we go along. The idea is not to learn about these services, but to see how we can leverage these services for your work. So to do any data engineering processing, we need to have some data set. So in AWS, we will put that data set in a service called S3. So you can have your data, we'll put it in S3, where you see the simple service and the object-based storage. If you use object-based storage, this is the ground file, and we can access that file. So once you have that, okay, shall I switch it off?
No, it should be good. I just turned the mic.
Okay, okay.
So hopefully it won't be back.
Okay, fine. So once we have the, I think it's not clear. Yeah. So I think once we have the data in S3 bucket, what we're going to do is we are going to process that data, right? So we will do some processing job, and this is where Spark will come into picture. Okay? And what we're going to do is we are going to use a service called Amazon EMR, which is Elastic Map Reduce service on AWS, where you don't have to worry about installing Hadoop, Spark, and all of that. It would be, you will be getting it out of the box as a service. And so all you have to do is you have to create an EMR service, and everything is set up. Then you can start your data processing using Spark or Scala or whatever you want. Okay, so we are going to use Spark, and once the data processing is done, after processing, we need to store the process data, right? Kind of a clean data. We will again save the data on S3. And once that is done, our processing part is over. Now we need to analyze it. So that means that we need to query that data. So to query that data, we are going to use two services. One is Glue. What Glue would do is, if you think about this, we started dumping the data here, and after processing also we get the data on S3. Now, if you see, data is in S3, but now to query the data, using SQL or anything like that, you need to have a metadata, right? Like what is the schema of your data? Right? So for that, one way to do that would be keep the data out of this traditional database and then run query. But that defeats the whole purpose of moving the data from a different place, which is quite a painful task. So we are going to do this group, which will help us to fetch the metadata or rather the schema of the data. So Glue will just go to the location, which is go to this location and find out the schema. So Glue will go to the crawl to your data and to find the schema. Once the schema is there, you can use Athena to query that. So Athena is a service which you can use for analytics purpose. You can just run SQL queries. Now, if you think about it, you are running an SQL query on an object-based query, right? And the reason that it is working because we have used Glue, kind of name, things for Glue, is connecting your data with your SQL engine. Okay, so now let's try to build this. Okay, so we'll start from S3. We will put some data there. We will process through EMR. Then we will use Glue to catalog that data. We'll find the schema, and then we will query that. Okay, so I'm just and all this code is there in the GitHub. So if you want to try out, you can always try out. Okay. Okay, so this is my AWS console. What I'll do is I'll go to S3 and I'm going to create a bucket, right? So first thing that you need to do is you have to create a bucket. So maybe I can name it as data con LA 2022, maybe 1. Okay, so this should be a unique name. So I'll just scroll down and create this bucket. So I got this bucket, and if you see here inside, okay, so we have this bucket created. Let me just go back. Yeah, we have this bucket created. Now we will create a couple of folders just for our own, for our own flexibility. I'll type input. This is where we will dump our raw data, and then we will create another folder called output. Okay, this is where the process data will be saved. And then we will also create one folder called code. Okay, so I'll explain why we need that. But since we are in the same console, let's create it. This is for future use. But for now, we can see that these are the two folders where we want to, we are going to use for our data processing. Okay, so we are done with the S3 bucket. Okay, so here, if you see, we are done with this part. Now we have to log into our EMR cluster and start the processing. But for that, we need to copy the data to S3, right? So let's do this. So we have this data set. Inside this, we have a wiki ticker JSON file, which is kind of a Wikipedia data for IRC chat with different channels and all of that. Others there in the I mean, it is there in the data set. It's open source. Yeah, it's there in the GitHub repo, and I'll, all the details are there in the GitHub repo. I'll open it up and show it to you. Yeah, sure. I'll share it with you. Okay. All right. So this is the data set. So first thing is I need to copy this to our S3 bucket, right? So let's do that. So our file name would be dataset. And our bucket name is -1, and I think it's input. Okay, so we have already uploaded the data, and if you go to this input folder, you should see the JSON data. Okay. So now what we are going to do is we are going to process this data. Okay. And now this is where we need to create an EMR cluster. So I've already created the EMR cluster. And if you want to see how it looks like, you can search for EMR. And here, what you can do is you can create a cluster. Click on create, you can give some cluster name, and you can see, you can give what version of EMR and what type of softwares or tools that you need, like Spark, Pesto, HBase, and all. You can define the number of nodes and create the cluster. As simple as that. I've already created this cluster, and this is where the value of EMR comes to the picture, where you don't have to worry about installing, configuring, and all of that your own. It will create a virtual machine on your behalf to install all of it.
And it was sort of great custom. You slide back and film back that screen.
What's that?
The screen you're on, you slide down.
Yeah.
I didn't know how you got to that screen.
Yeah, sure.
Maybe.
Yes.
Something.
Oh, okay. Yeah. So first you have to come to EMR. You have to search for EMR. And this would be your landing page. You will not see any of these because I have created a lot of clusters. Then you have to come to clusters and create cluster. Okay. And then you can just give few inputs and create cluster. But if you want to, add or customize the tools, then you can go to advanced settings and you can give some name, and you can actually select and unselect the services that you want. Okay. Or the, open source software that you want in your cluster. Okay. So I have already created this cluster. So what I'm going to do is I'm going to cancel it out. And this is the cluster which I've created. And after that, you will get the IP address or DNS name of this cluster, and you can do an SSH. Okay. And this is what I have done here. So I have SSH to this cluster. Now, what we are going to do now is, since this cluster has a Spark and PySpark, everything installed. Yeah, you have.
How large is that data set?
That is very small. I think few MB. And the reason I took this because I want to make sure that the project happens during that 20 minutes. Okay. Otherwise, the big data, process might go, run throughout the data farm. Right? So that's the whole idea. Yes, this is a where they have installed all these software. So if you go to here, and if you want to come to hardware, you will see that there are EC2 instances which are actually running. Auto scaling, yes, everything is in sector. Yeah. Okay. All right. So now let's see that what processing we are going to do. Okay. So we are going to do two things. One is we will aggregate some data based on these channels, right? Different channels we will aggregate, and we are going to filter out based on some, maybe based on some country. We have some country name, right? There are few entries which has country null and few entries with country like US and Canada and all of that. So let's see our code. So it's a pretty simple code. We are using PySpark, and first we have to make sure that we make our bucket name properly. Right, so I think this is the bucket name. Let's go back and see our bucket name. Can come to S3. I guess this is, oh, sorry. Datacon. Yeah, I think this is the bucket name, right? So you can just copy this and come here and paste it here. Okay, the same. So we have the input data, and these are the two places where we want to store our data after aggregation and filtering. Okay, these are the environmental variables I'm setting. And then this is my main function. I'm creating a Spark object, Spark session. I can give any name, and then I'm just reading the data from the input data source, which is nothing but that S3 bucket location. And here I'm just printing it out, how many data points I have using df count. And then we are aggregating this. Okay, so we are aggregating based on channels. So if you see here, we have lots of channel, right? So we have lots of channel like vi.wikimedia, then California, and so on and so forth. So we are just filtering it out, aggregating it based on channels. And the other thing we are doing is we are filtering. So we are filtering when this iRobot is false and the country name is United States. So there is a field called iRobot, isRobot, and where is it? I think it should be somewhere here. Yeah, if you see this, isRobot, right? So we want to make sure that we are filtering it based on this condition, and the country name is USA. But so the idea of this is you can do any filter, in your data. That's the whole idea. And then what we are going to do is we are just printing out the process data, and at the end is we are saving that data into S3. So if you remember, after this processing, we are sending this data back to S3. Okay, and this is what we are doing in this 4 lines of code. Okay, so we are writing it in that output data aggregation directory or the S3 path. Okay, so our yes, it does. Okay, so now let's try to. Okay, so if you want to go crazy, just try to type in one hand. It's quite a fun actually. Right, so, all right, so let's see. We are doing Spark submit and my code. Okay, so let's see how it works. So what is it is doing is now it is going to that Emr cluster, and it is running this processing job. And once this processing job is over, it's going to take the data back to S3. Right? And if you think about it here, the Emr cluster is not serverless, right? Because the EC2 is still up and running before we start this job. And that's why we interface to this Emr cluster and writing code, right? This part is not yet serverless as of now, right? And we will make it serverless, in a moment. But if you see this, it says the data has been uploaded, and we can see the schema. And the reason that we can see the schema is because we have mentioned that to print the schema. And now if you go back here to our console and come to the output folder, you will see 2 directories. And inside that you have this parquet file, which is the processed file. So now let's go back to our presentation and see where we are. So we have processed the file and it is there on S3. So this part is already over. So now we want to query that data, right? We have to see that whether the process data is, as per our need or not. So for that, we need to write some SQL query, but SQL query, we cannot run it on that parquet file directly, right? So we need to have the schema of that. So the service which will help us to do that is AWS Glue. So let's go to AWS Glue. Okay, and we can come to crawler. So AWS Glue can do a lot of things like data cataloging and ETL. For now, we will just use the data cataloging function called crawler. So we can create one crawler. So let's say data on LA crawler. Yes, no, you cannot. It's on your S3 bucket. You cannot read it from anywhere. But that's what we are trying to read here. No one has access unless under Glue give access. But if you want to access the data from your on-premise system, you can do that. Okay. So now this point onwards, everything is serverless. Okay. So what I'm doing here is I'm creating a crawler, and the crawler will read through all your data in your S3 bucket, and then it will create a schema on your behalf. Okay. So let's do that. So we gave a crawler name. So we have to give the path of our S3 bucket. So let's search here our S3 bucket name, datacon, and output, and select this. And we can click on next. We don't want to create another data source. And here we have to give some access. So I have already created one access because Glue is going to read the data from your S3 bucket, right? So it needs to have that access. So that's what this access policy is about. And this is the IAM role which we have. And then we can do it. We can run this crawler on demand or every hour or every minute based on your requirement. For now, we can say run on demand. Okay. And then since this will create a metadata, right? The schema, that is the table, that means tables need to be in some database, right? So first we have to create a database. So we can just simply click here and give some database name. So let's say food database. Okay, very innovative name, but let's say food DB, and let's create. And then we can click next. So we are not creating any database and all. It's just for your Glue to catalog your data. Okay, so there is no EC2 instance or anything of that sort, right? And now let's click on finish. So if you see this, we have this crawler, right? And what we can do is we have to run that crawler. So now what it is doing is now it has started and it is going to crawl through your S3 bucket, the location that we have mentioned, and it will try to figure out schema of the data stored in that S3 bucket. So this is happening on serverless. We have not provisioned any instance of using for that. Okay? And if we do that, and after that, you will see whether it has affected the table or not. So we have two paths, right? One is filtered and aggregated. If you see here, if you go to S3, if you see here, we selected this output path and it has two folders. Can you guess how many tables that it will create? 2 tables, right? It will create 2 tables. So let's see, let's wait for a couple of minutes and see how it goes. Okay. If you see this, it has detected 2 tables, right? And now if you go to tables here, and if you see this, maybe we should filter with database because I was just trying out yesterday. So if you see, there are the 2 tables which got created, right? Under this foo DB. And now if you want to see, now we can do the query, right? So now we have created this processing is done. Blue has created the catalog. Now we can come to Athena and query that. So let's go to, we can actually go to Athena here and go to that service, or you can just click on any of these database and come to action and click on view data. Okay, so it will automatically open up the Athena dashboard. So this is the Athena dashboard, and here you can run that query where it will read the data from your data data source from S3, right? So if you see, we have aggregated using the channels, right? So that's why we see all these channels and the number of counts. We have used group by, right, in that Spark job. Similarly, if you see, we also have a filtered data. And if you want to run that query, you can see that this is the filtered data for only United States. If you remember in the Spark job, we have mentioned that. So this is good, right? So it's working as expected. Now let's say we want to remove this hash in front of all the data. We forgot to process that, but we want to remove this, right? You can always run a SQL query to do that, but every time you have to remove, you have to use that same function in the SQL query to remove. So it would have been nice that we have removed it in the data processing time itself, right? So let's try to do that. Okay. So what we will do is we will add this one single line, which is going to replace after filtering, it is going to replace hash with with nothing, right? So what we can do is we have this code, and what we can do is after this, we will just add this line of code. Okay, so all we are doing is we are just modifying our code of processing. Okay, so let me save this file and let's run it. Okay, I hope that I've saved this file. Okay, so now if you think about it, I have not changed the input data source bucket name or output data source bucket name. And if you see in the code, we have mentioned override. That means it is going to override with the new data, right? So now we don't have to go and run the crawler again because the schema remains the same. It's just the data got changed, right? So now, once this job is over, as you can see, this job got over, right? So now we can come here and run the same query. Oh. Oh, okay. Yeah, sorry. Oh, why it's not changing? Oh, okay. So you have to change this. ODB. Okay, let's try to run it. See this? We got those things. Okay. So now the glue and Athena part was quite serverless, right? But the EMR part is still not serverless, right? That instance is still running, right? So if you come here and come to EC2 instance, you will see that that instance is still running because that is how we have created this EMR cluster. So these are the 3 instances which are running. Okay, so now EMR has come up with a serverless offering as well. Okay, where you can just create an application. This is the terminology that EMR uses, and then you get to submit the job. Okay? And for submitting the job, you could have the code in your SP bucket, and that's why we create that SP folder there. So let's try this out. First, what we are going to do is we are going to copy AWS S3 CP, and we can say code, and we need to give the code name AGG filter.py. Okay. So it got uploaded, and we have, if you want to go and see this, we have this code. Oh, created on the folder. Is that? Oh, okay. I guess. Oh, okay. So I guess I have. So. Okay, so we have this, file here, right? So now what we can do is we can get inside and go to the property and copy this name of this file. Okay, so let's delete this because I just got created because okay, let it be. It doesn't matter. So now what we have to do is we have to go to EMR. And we have to go to EMR serverless. So this got introduced just a few weeks back. I think 1 month back, it got GA'd. So now what we can do is you can come here and click on managed application. If you're doing it for the first time, you have to create that application. And then you are going to see some application. So if you're doing it for the first time, you will not see any application. You have to create that application, but I have already created that application. Okay, and it is stopped because there is no job running. It's serverless, right? So it will not have any resources. What you can do is you can come here and submit a job, and you have to give some name. So let's say full job. Okay, and you have to give some access. And you have to give the location of the script. This is the location of the script, and that's all. And you click on submit. Okay, so what is happening under the hood is now, AWS is going to find resources for your Spark. And if you are aware of having worked on Spark or you're part of Spark, so Spark is basically a distributed system where you can seeing every create computation platform where you can have your data in different places, or anywhere, or S3, and it can process your data on memory. If you're part of MapReduce uses quality the data and writing the data back to the drive, but Spark does everything in the memory. So In Spark terminology, we have a lot of things, when you submit the job, you create workers and do those kind of things. And there are different stages based on the query that, job that you submit. So in our case, for this particular job, which is that Python script that we have wrote, it might need for few stages, it might need 5 workers, for few stages, it might need 20 workers. So since it is serverless, you will be charged only based on, the workers of different stages. It's not like if any job needs 20 workers, you have to have 20 workers, based on, capacity based on 20 workers. Okay, so that's about it. So once this is done, you can do the Athena query and blue crawling just like that. Okay. So now coming back to the slides, if you want to take a look into this demo, there is a GitHub link. I can show it to you. I think this is the GitHub link that you were asking for. Is DataCon LA 2022. You have all this code with the data set, and what are the steps to do that. Okay. And the last thing is, I guess this slide will be shared with you at later point in time. I'll not go through this, but this is about serverless, EMR serverless. This is not that important, but just I kept it for your understanding if you want to get deep into serverless processing. Okay, so that's all about it. These are the resources that you can go over, and if you have any questions, you can reach out to me over LinkedIn or wherever it is. Right. So I did not want to bore you with the boring slide which you will get it anyway. Okay. So if you have any questions, I think we have a couple of minutes. So we have to move data into the so in this case, we are putting the data in the bucket. Yeah. So this is kind of, you have to have the data from the system. So if they want to put the data in the system, you can do a lot of things across different compute services within the and in fact, you can do it from your on-premise system as well. So the idea of big data is you don't want to move data from different systems. It's very cost intensive. So once you see the data in the system, you can do whatever. Yes. Yeah, that's the, I mean, it's highly useful and so you can put petabytes data. You cannot prepare any data. Yeah, yeah.
It's not, yes, if it's not in a stream, the mechanism to put it in a stream, I mean, it's going to saves the cluster.
Yeah. So if the data is on-prem, right? If the data is on-prem, you can also do that. Whatever we have done, you can also do that on your on-premise system. So in that case, you have to configure all the third-party tools for creating that PySpark cluster, right? And that is bounded by scale. Because today you might have a small data set, you want to do business growth, you have to buy more servers to create that cluster. But that's the
I think like the other guys kind of follow what you're saying. How do you get the stuff into the S3 bucket? If it's there already. Well, if you have an AWS cluster, you can put it.
In the same process, you use the connect to Python view of data, then push it to the PNC or EMR.
EMR, yeah.
You need the EMR with the same to the output.
Yeah.
Right.
Yeah.
So for the EMR cluster, can you add more, say you're using Python, you want to use some web scrapers or APIs.
Yeah. Yeah, sure. So you can do whatever you want. So EMR, you create an EMR cluster. Now we're not talking about the server. First, when you create an EMR cluster, you basically virtual machine is one of the software feeds first. Now you can actually use the storage of those instances to store your data. And how do you get the data on a is all up to you. When you use the or whatever. You can just have the data in different database and you can use the database. In fact, Athena is available to use to do the query. We are querying the data from S3, but you can do the query to any other resource system, the BigQuery, MongoDB, and all of that. So it has even RDS and different relational databases as well. So you don't have to have it on S3.
The question is, so if I set up the serverless one, right? I like not really see the AC instance.
Yeah.
And it's like not really manage what, like how am I do like practically go run my script? It's kind of more like automated.
Right, so in that case, if you want to data that you have with the server EMR is a script, right? In that case, you can mention where the data is. You can use the SDK to talk to, let's say, application data with RDS or maybe whatever. So as long as you have, you know, the input and output source of data mentioned in the script, and you have it active, remember we have to give an access, access policy, line policy. You have the access because Spark EMR is going to read or write data on your behalf. So as long as you have the role, I am role. I just missed when you were developing the Python. Is that the EMR up to that Spark and page 22? Yeah. Okay. Yeah. So okay. I already work. When I did that for server, I had to move the flow to S3 or somewhere. So that's why I put that. Yeah.
So he played in that game against
I just.
UC Davis that they lost. He didn't like the fact that I was there.
He's a good guy.
Yeah. He's done well there.
An incredible leader. Yeah. But
There's Garden. He's in there. All right. I should probably go get there.
You leaving up?
Yeah, if you want to watch it,
Yeah.
I'll put it on full screen.
It was in the Palo Alto office.
We still have one question.
Yeah, sure. Yeah, sure. I think,
Weird. Stay here in it. Oh, they can probably hear me. Hey, Garney.
yeah, that's very interesting. So you can actually run the whole Spark script in ETL, include ETL. It is like page, right? If you use EMR, then you have a lot of data, volume size more. But if you want to just do some small process and spread this, you can use that to do the ETL something. It can read the data from it. In fact, you can actually generate PySpark and scale code on your behalf. If you tell what you want to do. Okay? So, and also it can the moment you upload the data, you can detect the thing. You detect the response. Yeah. Okay. Yeah.
Following up on, is there only look at the bucket, only blowing up our data in the bucket, or can you put it any?
Any different sources?
Yeah.
So I think I'm not really sure I need to say what are the support I think I'm aware of three, but there are I think just being on using I will check that or you can take it out. But I think actually in other things, right, you don't need schema. The schema is already there. Right. The database randomly out. So that's fine.
So yeah, I mean, it's checking.
Okay, it's just checking.
Okay, got it.
Cool. All right, thank you so much for your time.
Thank you. Pleasure.
Yeah, we use like